This is a video for practice quiz for Standard 6. At the top of your paper, you see a function similar to the one that will be on your quiz. You have f of x equals x cubed minus 5x plus 12. So the first thing we're going to do is type that in Desmos so we can take a look at it. All right, so the first question says, identify the following and write as ordered pairs, relative min and relative max. I'm just going to sketch down here that our graph looks kind of like this. We have a relative minimum point down here where it's a low point on the graph, but it's not your lowest point on the graph. So I'm going to just click on it on Desmos and pick out those numbers. And then I'm going to round them to the nearest tenth. So that'll be about 1.37.7. And then we also have a relative maximum up here. It's not the highest point on our graph, but it is a high point in a certain area. So we say that would be negative 1.3, 16.3, which we can just use Desmos and click on those to find them, and then just round them off. So I'm going to move this out of the way. And that'll be it for number 1. It says describe the end behavior of the graph. So actually, let me draw that again real quick. This graph is pointed toward the first quadrant, which is positive, positive. So we would say as x approaches positive infinity, y approaches positive infinity as well. And then this other end of our graph is pointed toward the third quadrant where everything is negative. So at the top it said as x approaches negative infinity, we'd say y approaches negative infinity. And that's all you need for that question. Now let's look at number 3. It says find all the roots. Whoops. So let's bring up our graph because we don't have any to start with, and we're still talking about that same function we typed in. So if you just click on the x-axis, you get a real root of -3. So let's write use Desmos to find your x-intercept. That's your root, and that'll get you started. So we can use -3 to do synthetic division now. Our original function at the top of that page is x cubed minus 5x plus 12. So you want to think of it as x cubed plus 0x squared minus 5x plus 12. So let's put 1, 0, -5, and 12. Bring down the 1. 1 times -3 is -3. 0 plus -3 is -3. -3 times -3 is 9. -5 plus 9 is 4. 4 times -3 is -12. And we do end up with 0, which we should because we know that that was a root of our function. Then we could plug our variables back in. So we have x squared minus 3x plus 4. We know from our graph that this cannot be factored because it would have shown up as x-intercepts. So let's take what we have here and pick out a equals 1, b is -3, and c equals 4, and plug those into the quadratic formula. So x equals -b, or opposite b, so that'd be +3, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So we just need to clean that up. X equals 3 plus or minus, and then that would be 9 minus 16 underneath there, which is -7. So the square root of -7 is like the square root of -1 times 7. So all we're really able to do is take out I and just leave the 7. And just leave it like that because you can't divide by 2 because they don't all divide by 2. And then last but not least, we just need to write our roots. So we have x equals -3 was our real root we started with from our graph. And these two are imaginary. And you can just transfer it down there or draw an arrow for me so I know that you know these are your imaginary roots. All right. Number 4 says write out the factored form of f of x. So we're still talking about this original function at the top of the page. Your factored form comes from number 3. You have the root, which you found in your graph was x equals -3. That is not a factor. You want to write the factor as x plus 3. You change the sign. Then your other factor is from synthetic division. You want to bring that down as your other factor that's left over, because that's where those imaginary roots came from. But that would be a really nice way to just write factored form, and that's all we need for this one. And then that's all you have to do. Notice that's not a big box of space. Now number 5 is a different question. So we do not need the function at the top of the page anymore. And there is an honors versus a standard version. So if you're in honors, you could fast forward. And if you're in standard, you can just watch this first part. So you are given zeros and you need to find the polynomial in factored form. So 6 comes from x minus 6. But then we need to work on the plus or minus 3i. So let's do the sum and product of those. So I would just add them together because that's what the sum means. Let's type it in the calculator. So let me grab my calculator. Let's see. So I want Desmos, and I would like to have my calculator. So let's type in 3i, that second decimal to get that little I to show up, plus negative 3i. Notice it just cancels out. But if you're nervous, you can always just type in your calculator. So that's 0 over 1, and that equals negative b over a is our formula. The product is just to take those two things and multiply them together. So in your calculator, you could do second enter just to bring those back up, and then just go delete the plus sign, and you've got the product now. So that's equal to 9. The 1 at the bottom is understood to be there, so let's put that is equal to c over a. That helps us to pick out a, b, and c. So a is the number at the bottom. That'll usually be a 1 for our sake, for what we do with Math 3. 0 is at the top right there, so that's just your b value, and then c is at the top down here, so that equals 9. So we could say x squared plus 0x plus 9, but then we don't really write that 0x in our normal math, so we just leave that out. We just don't need it to be there, and we won't see it that way. We just need to bring over this other factor, x minus 6. And we're almost finished. We just need to polish it off with a y equals. And that is your factored form for number 5. And you can leave it like that. You do not need to multiply them together because that would be standard form. For honors, yours is very similar. We just need to put a little 2 in the front. So we have x minus 6, and then we need to do the sum and the product for the imaginary roots. So 2 plus 3i plus 2 minus 3i, and 2 plus 3i times 2 minus 3i. Your calculator can help you certainly to simplify those. So in this first part, 3i and negative 3i would just cancel, so this adds up to 4. We put it over 1, and we say that equals negative b over a. When we multiply them together, you should get 13. So I can show you over here in the calculator. You got 2 plus 3, and then I is second decimal, and then 2 minus 3i gives you 13 over 1, which is c over a. And so then we have a is equal to 1, b is equal to negative 4, and c is equal to 13. You just got to be careful with b, because that numerator is equal to negative b, so you got to switch the sign. So we could say x squared minus 4x plus 13 is where our roots that were imaginary came from. But we're working on factored form, so don't forget about x minus 6 was that original factor where 6 came from. And then you're finished. Do not multiply those together or you're headed for standard form, and they asked for factored form, so you just don't want to go too far.